Hi there, a very warm welcome, guys. I hope I'm audible and visible. Before I start saying any further, please give me a good to go. Let me know if I'm audible, if I'm visible. आप देख सकते हैं, सुन सकते हैं, सब sync है. All good? Hi Kumud. Hi Vivek. All right, you're audible and visible. Thank you, Kumud, for giving me a good to go because I really wanted that P block जो फोबिया लेकर आप बैठते हैं P block का वो आज मैं आपका दूर करूं. I have come up with very important reactions. Yes, when it comes to inorganic chemistry, I know that बहुत बदनाम है inorganic chemistry अपने exceptions के लिए, especially because of these all kind of series coming up, the YouTube shorts coming up, which keeps defaming inorganic chemistry. But if you look at the paper, अगर आप मेंस देखो या फिर एडवांस्ड का पेपर देखो, कभी भी कोई क्रैमिंग वाला सवाल नहीं पूछा जाता है. Either there are set of reactions which we all know are very important because we understood the pattern. How do we understand the pattern? We have gone through the previous year questions. Through those previous year questions, we know that this is a particular reaction which is repeating itself all the time. So we must remember those. So I have come up with those kind of reactions today. Number two, what are the concepts that comes up from the P block? So I am going to address today class 12th ka P block. Bole to group 15 to group 18. Am I going to cover everything? That's not possible, my lord. This is like the crispiest sessions which can be possible from a particular very important topic for the JEE. That's why I have come up with very important reactions throughout. जो भी आपका 15 to 18 में throughout important है, I have come up with that. So what is my expectation before I begin any further? My expectation is you sit here with the agenda to study, with the agenda to stay in the present moment, with the agenda to be in sync, be in resonance with me, with the agenda to write whatever important stuff we are talking about, and with the agenda of taking things with positivity. Okay, so with that, let's get started. See, if you get time, instead of, stalking here and there or spamming here and there, the best thing that you should do is you should open periodic table. I'll tell you, you can open up ptable.com. So that has a periodic table and a wonderful one which has been given to everybody. You can all access it. It has everything there, all the possible trends, all the possible chemical properties, all the possible isotopes, all the possible physical properties. Melting point will you find there? Yes. Boiling point? Yes. Radii? Yes. Everything. P table. So stalk that rather than stalking a profile on Instagram or looking at the devilish YouTube shorts which keeps defaming inorganic chemistry, and take out the phobia of inorganic chemistry from your head. Okay, so with that said, let's take a look at this periodic table which is highlighting beautifully. The spotlight right now is on group 15 to group 17 for today's session, but this whole is the P block, right? इसमें मेटलॉइड्स भी हैं, metals भी हैं, और कमाल की बात है non-metals भी है. So P block is a block that possesses not just metals but also non-metals as well as metalloids. That's the beauty. ठीक है? So Jayank, all important part. Get that point right. So let's get started. Let's see, when I'm talking about the basic stuff about the electronic configuration, first thing that should be hashtag HDCC, high definition crystal clear, is the configuration. What's the configuration? NS2, NP. It can be 1 to 6 when we are talking about any P block element. When I'm talking about the first members, look at it. I'm just striking off helium for a while. Let's not get confused with helium because it's just one right there which has 1s2 electronic configuration. an exception there, but then nonetheless, helium can be ignored for a while. Let's focus on boron, carbon, nitrogen, oxygen, and fluorine. You would always find out questions in one way or the other where these are asked, and you would see this show some kind of anomalous behavior. Why is there an anomaly? Can you all guess why is there anomaly when we are talking about boron, carbon, nitrogen, oxygen, fluorine? How is it that they're different from the other members of their individual groups? How are these first members different from the rest? Tell me, be participative. Come on. It has? Yes, क्या बात है कुमुद जिसवानी, क्या बात है, कमाल कर देता. So, बिल्कुल, what Kumud is saying is absolutely right because they lack d orbital. That's the logical explanation. They belong to the which period? Second period. And if they belong to second period, there is no d. And if there is no d, like a 3D or a 4D, their behavior will be different. What all things will be different? क्या क्या डिफरेंट हो सकता है, क्या क्या एग्जामिनर पॉइंट आउट कर सकता है. इस तरीके से याद करिए ना. एक एक प्रॉपर्टी कौन कह रहा है आपको उठाकर याद करने को. बिकम स्मार्ट. Inorganic chemistry requires your smartness, your creativity. So they would have small size, of course, like Lakshay said. They would have high electronegativity, of course. There is, of course, absence of d orbitals, and their ability to form pi bonds are much stronger because pi bonds is about the overlapping of what kind? The sidewise overlap. And if the sidewise overlap is happening, then the 2p will have a higher stability, right? And as compared to a 3p or a 4p overlap, right? Cool. So swastika, bang on. You have revised it for everybody. Higher electronegativity. There is absence of d orbital. There is more ability for the formation of p-pi bond. Bang on. Thumbs up, right? Now let's proceed further and look at a very important effect that you cannot forget. P ब्लॉक है तो किसी ना किसी तरीके से एग्जामिनर ऐसे नहीं कहेगा, लो बच्चों इनऑर्गेनिक केमिस्ट्री का हम इनर्ट पेयर इफेक्ट का सवाल ले रहे हैं. किसी तरीके से छुपे होते हैं ये कॉन्सेप्ट. पहचानना है. पिकापू, यू वुड हैव टू फाइंड इट आउट. इट्स अ हाइड एंड सीक गेम. Take it as a game, all right? So you know what inert pair effect is. You know that jaise we go down the group, the tendency to show the oxidation state, which is जो general trend है -2. क्यों भला? नीचे वाले जो elements हैं, why are they showing a particular oxidation state which is 2 less than the above ones? You know about the electronic configuration NS2NP 1-6, 1-2-6. Forget about 6. We are not talking about noble gas right now. They do not want to donate or they do not want to accept an electron, like you know. Right? So, ये आपको पता है कि ये इलेक्ट्रॉन्स हटा दिए ना NP वाले, तो ये जो 2 इलेक्ट्रॉन्स हैं इनको हटाना बहुत मुश्किल है. Why? It's a valence shell. You know, this is a valence shell. It's like that particular scenario. जो मुझसे पढ़े हुए हैं उनको पता है how we have understood it. It's like that kind of a scenario where the student has come in the class at the day of the examination and has taken the back seat thinking he will be able to cheat. But you know that all the friends which were there were so-called friends. One shouldn't have friends like them. They were like, look at this guy, he's all set to cheat. The backbencher who came with the idea to cheat in the examination hall, everybody is pointing out, look at him, ma'am. He's all here to cheat. So what will happen? The Z effective, the nuclear force, let's understand teacher to be the nucleus there. So the force or the attraction of the nucleus to the outermost shell will be higher, because of which this pair, since 2 electrons are here, right? This pair becomes inert. That's why the name inert pair effect. अब किन किन फॉर्म्स में ये आ सकता है? What all forms can you get? Now, understand that when I'm talking about the stability, can I put a question that which is going to be more stable? TlCl4 or TlCl3? Can you, TlCl2? Now that you know, thallium has a more tendency, this is TlCl, let me make one as +3, right? So let me make TlCl3 and let me write one as TlCl. Thallium chloride and thallium chloride, both of them are thallium chloride with thallium as +3 and +1. So if I ask guys 1 or 2, which is more stable? Which is more stable, 1 or 2? Will you be able to tell me? TlCl3 or TlCl, which is more stable? Come on, come on. Be participative. I will not move ahead till the time you give me the answer. So Kumud, why? Swastika, why TlCl? You guys are absolutely right. The second one, TlCl, is absolutely right. Siddharth is right. Sayam is right. Badal is right. No, Sayam is wrong. First is not stable. The second one is. The reason being? Bilkul, hypergaming is right. Avantika is right. Vivek is super right. So the reason is, of course, the +1 oxidation state for the thallium is more stable as compared to +3. Hello, knock knock, who is it? Inert pair effect. In disguise. Not blatantly. Which of the following pairs will show inert pair effect? No, nobody asks questions like that directly on the inert pair effect. But stability ka sawal ho gaya. Which of the following is more stable? Which is least stable? Which will immediately undergo dissociation? If these kind of questions are coming, think from the perspective of inert pair effect, right? Now let's move ahead, talk about 15 to 18. These were the general things that we were talking about. Now let's focus on class 12. Okay? Now I want you to first look at the atomic and physical properties like that for very quickly. These are the questions which are based on the trends. And the trends is something that you have done in periodic classification. So basically these are questions of periodic classification, but the question will have options that contains p block elements from 15 to 18, right? So what we know is general trend, for example, as we talk about the atomic radii, as we move down the group, the atomic radii increases, everybody knows. General trend, as we move along the period, the atomic size decreases, everybody knows. Can there be exceptions? Yes, my lord. Where can there be exception? If there is a half-filled electronic configuration or a fully filled electronic configuration coming in, we will become extra vigilant. ये जो आपका सवाल होता है ना मैम, हमें कैसे पता चलेगा? हमें कैसे पता चलेगा? हाँ भाई, जितना समय आप बिताएंगे एक कॉन्सेप्ट के साथ तभी पता चलेगा. So it's very important for you to spend time with the concept in order to grasp it, in order to understand it, in order to embed it. Then only the right thing will strike at the right moment. You may remember, but it may not strike when you are in the examination hall. What's lacking? You're spending the time with the subject, with the positive outlook. So make sure that you understand wherever there can be exceptions. The reason might be, they're just handful of reasons, yeah. Just handful of reasons. Keep them in mind. Why the general trend is all should have oxidation state +3, but one is having +1. What can be the reason? If there is a pair going, inert pair effect. Similarly here, effective nuclear charge yet again can be the reason, right? Okay, so now if I'm talking about the exceptions here, keep in mind noble gases have the highest atomic radii in periodic table. How can you explain this statement? आस्था गुलाटी, जहां इनऑर्गेनिक आई वहां आए एक्सेप्शंस. बिल्कुल, बट एक्सेप्शंस बहुत लॉजिकल होते हैं. बहुत कम वाले सवाल होते हैं जहां पे एक्सेप्शन वाली चीजें पूछी जाती है. अदरवाइज थिंग्स आर ऑलवेज मैनेजेबल एंड इज इन द रेल्म ऑफ आवर एक्सप्लेनेशन. I agree, when it is about inorganic chemistry, first we ask the answer and then we give the explanation. We chemist, I'm talking about. How the chemists or the scientists go about explaining inorganic chemistry. They want to know the behavior and then they will devise some explanation. And so many places there are cumulative effect as the explanation. Cumulative, एक effect नहीं है. Get that? So, okay. Harsh is saying fully filled orbital, तो उससे क्या होगा भाई? Fully filled है तो क्या हो गया? So what? How will it have? It should have, if the protons are increasing, so are the neutrons. So the force on the outermost shell should increase eventually, right? That's a trend. Fully filled orbital is not the answer. Let's say it is one of the options, but Harsh, it is not the answer, okay? Why is it so? Atomic radii is maximum. Why? Nothing about the well-wisher. Let me tell you nothing about the nuclear charge here. How to become organic specialist. Spend more time with it, Sameer. It will open a ways for you all automatically. Bilkul, Abhinand, Rajiv is saying, but shouldn't they have the smallest radii? Question mark. That's what I'm asking. Exception is there. Why is this exception here? They should have. You're right, they should have had. But there's something different. Suman Rani has given absolutely right answer. Very good. Noble gases have van der Waals radius. Very good. Suman Rani has absolutely given the right explanation here. What are we counting here? See, for others, we are either finding out the ionic radii and hence evaluating the radii, or the covalent radii and hence evaluating the radii. But this doesn't form any kind of a, molecule like He2 or Xe2 doesn't exist. So what we are finding for them is just the van der Waals radii. And what's the van der Waals radii? आपको मैं बता चुकी हूँ कि van der Waals जो है weakest forces of attractions होते हैं. It's like, let's say, two Indians in India. If let's say I meet somebody in the market, will I say, oh, hi, how are you, to a random stranger? No, right? You do not greet everybody. But let's say you are there in a different country. Let's say you are in Greenland, let's say, and you see some Indians speaking Hindi there, or you see some Kannadiga there and speaking Kannada there. What would happen? That Indianness would increase. So otherwise, these forces of attraction, which is, let's say, being Indian, was not of particular importance when we were in India. But when there are no other forces of attraction, like when you were in Greenland and you met another Indian speaking with you in your native language, then you would want to say, oh, hi, where are you from? You might start a conversation. That means a force of attraction which was absolutely of no importance became of importance, you being an Indian. So is here, van der Waals forces of attraction are like that. Think of them, they are very weak, unlike covalent where, there's some sort of overlapping, or unlike the cation and an anion where one has given and one has accepted the electron. But here, what do we have? They're far apart and hence the radii will be maximum when we are talking about the van der Waals radii. Got that? That's the reason what we are evaluating for the noble gases is the van der Waals radii, and that's why van der Waals radii tends to be the highest, and that's why they have higher atomic radii. No other option. Right? ठीक है, चलिए फिर आगे चलते हैं. Now talk about the ionization enthalpy as we go down the group. It's easy to remove an electron as the atomic radii is increasing, but as we move along the period, the ionization energy decreases, right? Okay. Now, if I'm talking about the electron gain enthalpy, examiner loves one kind of a question. Come on, let me ask you this. Question number 1 to you guys. Oxygen or sulfur, which has higher electron gain enthalpy? Option A or option B? Come on, come on, come on. Option A or B? P block को समझना है तो enjoyment के साथ पढ़ें. In the moment रह के पढ़ें, present moment में रह के पढ़ें, अपने आप मजा आएगा. So be very participative. Okay, Ravi is saying B. Mohammed is saying B. Oxygen. Well-wisher is saying oxygen. Yogi is saying A. Sayyam is saying A. Vivek Mishra is also saying A. Storm Rokers is saying B. So, of course, when we are talking about electron gain enthalpy, of course, it is sulfur which is having more electron gain enthalpy or electron affinity as compared to oxygen. ठीक है? Reason is very simple. भाई imagine करो, जिन्होंने मुझसे पढ़ा मैंने उनको बताया था कि अगर आपके पास एक 1 BHK है, 1 bedroom, hall, kitchen, 1 BHK, and आप रह रहे हैं वहां पे और वहां पे there is sufficient just for you, not for anybody else. But let's say somebody else also comes in and says, I want to stay with you, I will be staying here for 3 months or 2 months. Of course, that person will be highly unwelcome. The person has already very limited space. There's just one washroom. It's all cluttered. There is not enough space for anybody else. So that person would not want an electron or, let's say in our case, another guest. But if somebody has a big bungalow which has many guest rooms, it has guest room, so that person would not mind if a person comes in. He was like, oh, I was already alone in that house. Thank God I got a company. You stay for whenever you want because that person was a friend, right? But here also it was a friend. No matter how good a friend was, I'm sure after like 1 month he will turn out to be an enemy. And there'll be a lot of bitching happening, right? So what is happening here in terms of oxygen and sulfur? This 1 BHK is oxygen and this big bungalow is sulfur. Sulfur has d orbitals. If sulfur has d orbital, it's like it has guest rooms. Okay, you can come and stay, it doesn't matter. So that's why you would see that sulfur wins over oxygen. Similar trend you see for the fluorine and chlorine. Same thing. Control C, Control V. Same thing. So remember this. Oxygen has more electron gain enthalpy as compared to sulfur, and the chlorine has more as compared to fluorine, even though you know which is more electronegative. Out of fluorine and chlorine, so this is, guys, electron gain enthalpy, but if I talk in terms of electron negativity, which is the ability of an element to attract a shared pair of electrons towards itself, of course, fluorine will be more than oxygen. And similarly, when I'm talking about fluorine will be more than, as compared to chlorine I'm talking about. So fluorine will be more as compared to chlorine. And oxygen and sulfur, when we are comparing, oxygen will be more than sulfur. Even though the order of electronegativity is this, order of electron gain enthalpy is this. Because it's about accepting an electron. And the one who is hungry will accept the electron. Right? Bingo. Now let's proceed and talk about these exceptions. Once again, due to the small size of oxygen and fluorine atom, there are strong inter-electronic repulsions in the relatively small 2p orbitals of oxygen fluorine. Thus, the incoming electron does not experience much attention. Okay? Simple. अपना 1 BHK और big bungalow से याद रख लीजिए. Simple thing to remember. सही है, फिर आगे बढ़ते हैं. Let's talk about electronegativity that we have already talked about. Everybody knows that out of these, fluorine, oxygen, nitrogen, Phon is the order. right? Fon, F-O-N, fluorine maximum, then oxygen, then nitrogen. This is like super simple. अब बात करते हैं metallic character. Of course, as we move down the group, metallic character increases. As we go along the period, the metallic character decreases. The non-metallic character rather increases, right? So this everybody knows. Now let me come here. ठीक है? Boiling point, melting point. Boiling point, bachcha party, understand it from the attraction. Wherever there are more forces of attraction, there will be more boiling point. Melting point, understand it from the symmetry. Symmetry, understand it from how the molecules are going to sit, in this case, atoms are going to sit together. If something is very symmetric, the melting point will be high. If something is less symmetric, melting point will be less. If there are, when I'm talking about boiling point, if there are forces of attraction, let's say, which are hydrogen bonds, the boiling point will be high. The second force of attraction is the dipole-dipole. You know, hydrogen bonding is also dipole-dipole interaction, but the strongest dipole-dipole interaction, hence we have given it a new name, hydrogen bonding. But the other one that aces it is dipole-dipole. Then you know dipole-induced dipole. So you know the van der Waal, all other van der Waal forces in the order. So keep them in the mind, and you know that they simply depend on either the surface area. More the surface area, more will be the van der Waal forces of attraction, or they will depend on the molecular mass, right? But let me tell you, polonium here is an exception. अब why पूछिएगा तो वही है, राज यही है कि राज को राज रखने को बोला गया है. राज है यहाँ पे कि ये पोलोनियम जो है, it is such a heavy metal, but yet you would see it has a very low melting point. In fact, it has a low boiling point also. What the reason is, we always give cumulative effect reasons. There's not one reason responsible for anything. कभी भी किसी भी चीज का एक रीजन हो ही नहीं सकता. Nothing is absolute. You are where you are not because of one factor. There are multiple factors. Similarly, when we are talking about polonium, maybe because you know that it has 32 electrons more as compared to the above one, right? So when we are talking about tellurium and polonium, tellurium has 32 less electrons as compared to polonium. Kahan gaye polonium mein? That too, the electrons in the polonium has either entered D or F. These two, D and F, are already known for their poor shielding effect. Since they're known for the poor shielding effect, you know they would show something anomalous for sure. Right? ठीक है, अब हम बात करते हैं भाई, पहला एक्सेप्शन पोलोनियम is deadly and used in missions. योगेश गौतम ने बहुत इंपॉर्टेंट बात कर दी, very important. Yes, it is used as a nuclear, it is used in the it's a radioactive element. In fact, कई बारी आप देखेंगे बहुत सारी कार्बोनेटेड रिंग्स है जिसमें पोलोनियम मिलता है. In fact, cigarettes में भी पोलोनियम मिल जाता है. You know that? So it is very readily found in your surrounding. It is a radioactive element, right? But relatively, you've understood melting point come, boiling point come. Now the next one is another exception that I want you to note because it's important from the JEE mains as well as advanced perspective. Look at this. Arsenic we are comparing with antimony. Look at this, arsenic melting point हम कह रहे हैं ज़्यादा है antimony का. Again, the reason is similar. When we are talking about antimony, the electrons are entering more into these D and F, which is causing problem, and that is why जो arsenic है is relatively willing in terms of the melting point, right? Okay, next one, compounds of P block elements. अब हम करने वाले हैं. We'll go side by one, one thing at a time. Like for example, I'll take hydrides and then oxides and then maybe the gas N2 and so forth. ठीक है? चलो. बिल्कुल. Uncertainties chemistry. Thank you for pointing that out. Polonium was discovered by Madame Curie. Yes, Indeed. Madam Curie, the lady out there, we have just two females in the periodic table. One is Madam Curie. On the base, on her name there is another element though, but she has discovered polonium. That's true. Right? Okay, now I'm going to enter hydrides. हाइड्राइड एंटर होते ही कॉन्सेप्ट कौन सा चमकना चाहिए? कॉन्सेप्ट चमकना चाहिए कि ड्रैगो कंपाउंड्स क्या होते हैं. What are Drago compounds? So you know that if I talk about the periodic table, these are the elements. When they are present with hydrogen, we know that there is something wrong there. They're Drago compounds. Their bond angle will be closer to the 90°. What else happens in the Drago compound is the element, whatever element that we're talking about, can be any of these: phosphorus, arsenic, antimony, bismuth, sulfur, selenium, tellurium, polonium, can be any of this. And if this element which I'm representing with E is making a bond with H, breaking this bond will be easy. If breaking the bond will be easy, of course, they can act like a reducing agent, maybe, can reduce others. Bond angle 90 degrees. So there are many questions possible from here, right? So let's get started with the thermal stability first of all. As we're going down the group, the thermal stability is decreasing. Why? Because BiH3 has even poor overlapping as compared to NH3. NH3 has hydrogen bonding rather, right? So because of the strong forces of attraction, NH3, higher hydrogen bonding, of course, hence will have the higher thermal stability. Whereas when I'm talking about bismuth with hydrogen, that's a Drago compound, right? Well, now the next one is the reducing power. It increases as we go down the group, right? As the reducing power is increasing, because hydrogen can easily be available, right? So of course, down the group, we can say the reducing power increases as we go down the group, right? Next is boiling point. Wherever you see the stronger forces of attraction, like ammonia, like water, like HF, higher boiling points. Exceptions. Otherwise, you know the rule, boiling point will be proportional to the molecular mass. As molecular mass increases, the boiling point should increase. Next is the oxides of nitrogen. Oxides of nitrogen में ये सब हैं. क्या कॉन्सेप्ट हमने स्टार्ट करते हुए बात करी? नंबर वन, व्हेन वी वर टॉकिंग अबाउट हाइड्राइड्स, व्हाट्स द मोस्ट इंपॉर्टेंट इज द ड्रैगोस कॉन्सेप्ट. Number two concept, which is most important when we are covering all these oxides, is your knowledge of making structures of oxygen containing compounds. ये क्या होता है भला? Whenever you have to find out the structures of the oxygen containing compound, calculate oxidation state निकालिए. If it is greater than the maximum oxidation state, the compound is supposed to have a peroxy linkage. Mind you, but should be very carefully used. It is not applicable for H2O2 because वो oxygen का ही compound है. Oxygen ही central atom है. Here we are talking about oxygen being the side atom. The other is calculated oxidation state is equal to the maximum oxidation state. वहाँ पे oxy bond होता है. Think of it as MOM, where M can be any element. And where calculated oxidation state is coming out to be less than the maximum oxidation state, there we will have element-element linkage. So this is the first place from where the questions are possible. For example, let's check N2O, guys. N2O, क्या ये NON इस तरीके से तो नहीं है? How do we know? How do we know? Let's check. So you know that nitrogen, I can write it like this: 2x minus 2 is equal to 0. So 2x is equal to 2, so x comes out to be equal to plus 1. Calculated is less than maximum, right? That means it will have element-element linkage. Hence, you know how the N2O structure should look like. We'll talk about it. But this is the first hack that you need to keep in your mind. Like Swastika is saying N2O5 has peroxy linkage. Let's test whether Swastika is right or not. N2O5, nitrogen, 2x minus 10 is equal to 0. So 2x is equal to 10. So x is equal to 5. That means calculated is equal to maximum. If calculated is equal to maximum, then we will have NO-N bond. Swastika, not a peroxy linkage. Oxy bond. It will have an oxy bond. Got that? तो पहला ये hack है जो मेरे ऊपर लिखा हुआ है. Deserves there. It deserves a position above my head for sure. सर पे बिठाओ इस concept को. Very important. अरे स्वास्तिका. NS2 NP3, 3 इलेक्ट्रॉन यहाँ से 2 यहाँ से, +5 कैन बी द मैक्सिमम ऑक्सीडेशन स्टेट. नाइट्रिक एसिड +5 कहाँ हो, क्या हो गया? बात चली तो दूर तक चली गई क्या? प्लीज ऑक्सी बॉन्ड यहाँ पे चेक कर लीजिए, जिसमें भी डाउट है. चेक इट फॉर N2O4. लेट्स टेस्ट N2O4. 2x minus 8 is equal to 0. So 2x is equal to 8. X comes out to be equal to +4. Calculated less than maximum. So N bond will be there. So N2O4 looks like this. You can make it for any compound here for the oxygen containing compounds. So this I want everybody to keep in your mind. Thumbs up. Let's get started with the first one, N2O, nitrous dinitrogen oxide. The other name is nitrous oxide, right? N2O. You know that it is also famous as a laughing gas, है ना? Is it a recreational drug? Yes. Is it banned? Yes. So I'm sure अगर आपने सुना है, it's a very famous, famous thing that everybody knows. It's not a secret. So Osho was given this N2O when he was in a later stage of his life. N2O, laughing gas it is. What is the structure? Now you know. How can it be prepared? Very simple, guys. All that you have to do is ये जो अमोनियम नाइट्रेट है, निकालिए पानी यहाँ से, H2O निकालिए. हाइड्रोजन जितने भी हैं सभी निकालिए, जितने पॉसिबल है इवन रखना है, बस ये कंडीशन है. I'm repeating it in English because I do not want anybody to miss it. I want you to eliminate water molecules. How many water molecules are you supposed to remove? Whatever is allowed. For example, if I have NH4NO2, here also I can remove 2 H2O, right? 4 hydrogens are here, 2 oxygens are here. Here I remove 4 hydrogens and only 2 oxygens I can remove. Then only I will get 2 water molecules. What is left now? Let's see. So for these kind of structures, for these kind of equations, the trick I am giving you. Whenever you're decomposing, heating ammonium salts, remove water, guys, and see what you get. So 2 water molecule only you can remove, and you will see that one of the oxygens is left and 2 nitrogens. So what you end up getting is N2O. Whereas let's say if I'm taking ammonium nitrite, NH4NO2, I can remove 2 water. What is left is 1 nitrogen here and 1 here. So N2 will be removed. Okay. ठीक है? चलो. Next one, N2O का structure. Thumbs up. Okay, you know that it was used, I should say. It is no more used. We have much better anesthesias now. So used as an anesthetic and also known as laughing gas. Now let's enter into the nitrogen monoxide, NO. NO में क्या हो रहा है? Preparation simple है. आप sodium nitrite, NO2, you can see NaNO2. So we have NO2 minus. X minus 4 is equal to minus 1. So X comes out to be equal to plus 3. You need to oxidate. You can see that you can easily converted into NO where nitrogen is in +2. Sulfur is in +6 and you can see that sulfur का कोई यहाँ पे sulfate है, कोई change नहीं है. Iron from +2 is going to +3. तो अगर आयरन का हो रहा है ऑक्सीडेशन विद द हेल्प ऑफ सल्फ्यूरिक एसिड, यू विल सी नाइट्रोजन का हो रहा है रिडक्शन. इट्स अ बेसिक रेडॉक्स रिएक्शन. हाउ कैन यू प्रोड्यूस नाइट्रोजन मोनोक्साइड कैन बी आस्क्ड. होल सीरीज वाले क्वेश्चंस होते हैं, एक पार्ट, दूसरा पार्ट, तीसरा पार्ट, राइट? So you must know how we must prepare NO. So this is simple. You may use sodium nitrite in the presence of FeSO4. FeSO4 है तो H2SO4 होगा ही. And iron will undergo oxidation from +2 to +3 and nitrogen will undergo reduction from +3 to +2. As simple as that. Next one, look at this. You know it's a free radical. It's an odd electron species. It is an odd electron species yet colorless. So it's a colorless gas. Okay? Well, I'm talking about now the nature of it. It is an odd electron molecule. Hence, the gas is paramagnetic. It is paramagnetic. But color iska colorless hai. Right? Okay. Now, if I talk about N2O3, let me tell you, by condensing equimolar amounts of NO and NO2 together, you can make this N2O3. Or you can simply oxidize this NO to N2O3. Remember it. मैम हमें कैसे याद होगा? See, आपको कैसे याद होगा? सिंपल है. आप एक बारी लॉजिकली सोचिए, NO NO2 क्या ही दे सकता है? Both the nitrogens will combine together. Both the oxygens, like all the three oxygens can combine together and will give you N2O3. Right? So uncertain chemistry, it's stable enough. Why don't it dimerize? It is stable enough as compared to, you know that things are ought to form dimerization when it is incomplete in itself. अपने आप में incomplete है, मतलब अपने आप में unstable है. But अगर ऐसा possibility है कि एक इलेक्ट्रॉन को संभालना है और एक ही सेंटर है, नाइट्रोजन का एक ही तो सेंटर है, there is not much. And nitrogen or oxygen में nitrogen is more electronegative, less electronegative, so possesses relatively a delta plus. So a delta plus would relatively like an electron, right? Would not want to dimerize and show, unlike the NO2, वहाँ पे दो oxygens हैं. It can stabilize itself by forming N2O4, which is turning out to be more stable. So things are always relative and life is all about stability. Here also look at this, NO जब oxidize हो रहा है, so NO का oxidation से भी आपको N2O3 मिलता है. ठीक है? Next thing is the NO2 now. NO2 का एक reaction तो हमने अभी देखा, right? Let's see now the lab preparation of lead nitrate. This is also giving you NO2. The very important connecting dot for you will be this. The connecting dot will be red-brown gas. Red-brown gas. So, when I'm talking about the structure, everybody knows here there is a odd electron. And this is not stable enough. You can see it has, of course, two oxygens which are attached to it. And the shape is also bent. There with NO, we know that this shape was linear. You know, if it wants to, let's say, if we idealize this scenario, okay, every free radical wants to dimerize. Let's say it forms a bond. It is very difficult to have such a big linear molecule as a stable one. Imagine the product and you would automatically think of it, no, this doesn't look right. NO here and NO here, all linearity is what? Because this is also sp hybridized. This is also sp hybridized. Nitrogen making 4 bonds, so I'm putting a plus here. Do you agree? that this is not stable, but yeah, this is of course stable because here we have bent, so this can help, this can be of real help. So it undergoes dimerization to give you N2O4. So now the next thing is N2O4 itself. So let's understand N2O4. The preparation is NO2 को आप dimerize करेंगे. NO2 में आपको पता है it was an odd electron species, so it was paramagnetic as well as colored. Whereas N2O4 is diamagnetic and colorless. It has a single electron. Yes, I showed you the structure. Check out the structure once again for NO. Look at this. The answer lies in your understanding. So this is a lone pair. If I put it like this, do you agree it looks something like this then? Right? And this is also something that you would find out. कहाँ से देख सकते हो आप? Molecular orbitals. आप MOD बना सकते हो, molecular orbital diagram. And you would know, right? ठीक है, अब हम नेक्स्ट बात करने वाले हैं N2O4 इज सॉर्टेड कि NO2 डाइमराइज हो रहा है, N2O4 दे रहा है. अब आप देख लीजिए, नेक्स्ट वन इज N2O5 विच लुक्स लाइक दिस. HNO3 रिएक्ट कर रहा है P4O10, आपको दे रहा है N2O5 जहां पे ऑक्सी बॉन्ड है. ठीक है, अगर हम बात करें नॉर्मल N2O5 के बिहेवियर और स्ट्रक्चर और बॉन्ड एंगल इन सब की, सो वो आप इजीली कैलकुलेटेड ऑक्सीडेशन स्टेट और मैक्सिमम ऑक्सीडेशन स्टेट से कंपेयर करके यू कैन ड्रॉ. सो बिफोर आई प्रोसीड टू द नाइट्रोजन, लेट मी टेल यू द 3-4 वेरी इंपॉर्टेंट कॉन्सेप्ट्स दैट वी हैव कवर्ड हियर. ड्रैगो कंपाउंड्स हम कर चुके हैं फॉर द हाइड्राइड्स. फॉर अंडरस्टैंडिंग द ऑक्सीजन कंटेनिंग कंपाउंड्स, द ऑक्साइड्स ऑफ द नाइट्रोजन, वी हैव talked about the trick calculated oxidation state, maximum oxidation state. We have talked about जो nitrates है या nitrites है उसमें से कैसे आप पानी निकाल कर you can come up with what will be formed, right? And also please make sure NO doesn't dimerize but NO2 does, and इनका NO is a colorless gas but NO2 is colored, and dimerization के बाद देती है colorless gas diamagnetic which is N2O4. ये है important takeaways. Inorganic जब भी आप कर रहे हैं, make sure you're revising whatever you have done in the past, let's say 1 hour when you're revising it. These sessions are for the revision. I can't start and teach here. I'm just giving you all that is important. So you have to come little warmed up. Then only we can have a constructive exercise here. Then only a possible good workout is possible, है ना? Otherwise, अगर warm up करके नहीं आओगे, of course you'll have cramps. With that, let's move on to the dinitrogen now. We are talking about dinitrogen. Ammonium chloride NaNO2 के साथ ammonium nitrite दे रहा है NH4NO2 plus NaCl, और फिर हम हीट कर सकते हैं अमोनियम नाइट्राइड को, हमें मिल जाएगा N2, जैसे मैंने आपको बताया कि रिमूव वाटर. सिमिलरली आई एम टॉकिंग अबाउट ऑब्टेन बाय अमोनियम नाइट्रेट. देखिए यहाँ पे NH4 के साथ तो चला गया NO2, फिर आपको मिल गया NaCl. तो यहाँ पे हमेशा डबल डिस्प्लेसमेंट, कौन किसके साथ व्हाट पार्टनर्स आर बीइंग एक्सचेंज्ड, ओनली दैट यू हैव टू रजिस्टर इन योर माइंड. Once you've registered in your mind, this becomes easy equation to remember, है ना? अब हम बात करते हैं नेक्स्ट, एक और अजाइड्स वाला फेवरेट है एग्जामिनर्स का, दी फेवरेट. बेरियम अजाइड हो गया, सोडियम अजाइड हो गया, एंड इनफैक्ट दे गिव प्योर, वेरी प्योर. ये पता नहीं कितनी बार पूछ चुका है एनटीए, कितनी बारी एग्जामिनर पूछ चुका है प्योर नाइट्रोजन यहाँ पे किन प्रोसेस से मिलेगी. यू वुड सी एन अजाइड देयर, दैट अजाइड ऑन हीटिंग विल गिव यू द प्योर नाइट्रोजन. What can I do here? Nothing. You need to remember this, that's it, right? So now let's enter the chemical properties. When I'm talking about the chemical properties of nitrogen, everybody knows the bond order is 3. Bond order 3 है. N2 is inert at room temperature. We know that. Okay, if I'm talking about the higher temperatures, we know it will form nitride. Now, azide is different. Look at the formula that I showed you when I was writing azide. There's a N3 with the minus above. Right? But when I'm talking about nitride, it is a N3 minus. Above there is a minus along with the 3. So do not get confused. This is azide. This is nitride. Rest of the game is like the junior level, cross multiply. So let's check out here. When I'm talking about lithium, lithium plus 1, N3 minus, cross multiply, we get Li3N. Magnesium 2 plus, N minus 3, cross multiply, Mg3N2. Wonderful. So it's no rocket science to remember these. ठीक है? अब हम बात करते हैं next. Dinitrogen combines with oxygen only at a very high temperature. So very high temperature, of course, 2000 Kelvin is what we're talking about. So nitrogen बहुत unreactive है, ये हम कह सकते हैं. You can see the kind of temperature which is required for it to actually form an oxide, which is NO. ठीक है? तो NO आपने register कर लिया है. ऑलरेडी आपको पता है डाइमराइज नहीं होता है, कलरलेस है, पर पैरामैग्नेटिक है, ऑड इलेक्ट्रॉन है. नेक्स्ट अमोनिया. अमोनिया आते ही हमें ऑफ कोर्स हेबर्स प्रोसेस तो पक्का चमकना चाहिए. हेबर्स प्रोसेस कैसे है? बिफोर दैट लेट्स सी द यूरिया वाला प्रोसेस मैन्युफैक्चर्ड बाय यूरिया. सो NH2CuNH2 को आप अगर पानी के साथ डालो तो अमोनियम कार्बोनेट मिलता है. अमोनियम कार्बोनेट हमें अमोनिया दे देता है, बट द यील्ड इज पुअर. So that's why enters the lab method where we are of course going to use Haber's process. Right? बिल्कुल सही कुमुद, सही बोला. अब ये बताइए मतलब Haber's process, everybody knows that Fritz Haber got a Nobel Prize for this particular reaction, these particular reactions that you are going to witness, where we're going to produce ammonia. But do you know that it was produced because somebody was in a hunt of a war gas? War gas के लिए बनाया गया था. The intentions were not that पूरे world का food का जो problem है वो resolve हो जाएगा, because you know ammonia is very important for making fertilizers. And it brought in a revolution because we used ammonia as a fertilizer. तो जब हमने अमोनिया को फर्टिलाइजर की तरह यूज किया तो of course it's a noble thing, but the idea behind ammonia ka formation was not noble. Rather, those were the times of World War. Like somebody was mentioning, yes, right now also the situation which is going on in the world is very tenseful. So everything has ripple effect, butterfly effect. If something is happening in Russia and Ukraine will certainly affect India in terms of everything, है ना? पर हाँ, आपके जो dates आ गई हैं JEE Advanced की, everybody knows it's 3rd July now, तो वो चीज़ hamper नहीं होने वाली, so do not think much. That's why I'm saying intention पता होना ज़रूरी है, इसलिए अपना intention भी clear रखिए. Here when we are talking about the guy Haber, yes, the intention was to use it as a war gas. और एक्सप्लोजिव्स बनाने में बहुत मदद करती है अमोनिया. ठीक है? सो हियर क्या करते हैं हम, N2 और H2 को कंबाइन करके NH3 बनाते हैं. आप देख लीजिए कितना सिंपल है. Environment में नाइट्रोजन इज abundantly present, almost 71%, and hydrogen is abundantly present. So of course we can use it and make ammonia, right? Well, this is simple. Here what is important for you to know is activation barrier for the dissociation of N2 and H2 is in the gas phase is high. इसलिए without a catalyst the reaction between N2 and H2 occurs very slowly. ठीक है? तो catalyst क्या है भला? This is a particular question in itself. You must know it. You must know it. क्या है? Iron oxide with small amount of potassium oxide, K2O. Think of it like this, K plus 1, oxygen minus 2, cross multiply, we get K2O, potassium oxide, and Al2O3, alumina. ठीक है? Earlier, iron was used as a catalyst with molybdenum as a promoter. So, this factual thing coming your way can be asked as a direct question. Okay? अब चलते हैं भाई लोग chemical properties के पास. Chemical properties, it forms ammonium salts with acids, जैसे कि NH3 with HCl is forming ammonium chloride. Everybody knows NH3 has a lone pair. It can act hence like a base. It's a Lewis base. So NH3 plus HCl gives you NH4Cl. Ammonium chloride की खास बात ये है कि this is like a coordinate bond that you can imagine, number one. So ammonium chloride has a coordinate bond also. You can think of the charges also coming up. You can write it like this, NH4 plus and Cl minus. So there will be ionic bond also. And of course, when we are talking about NH3 and HCl, they have individually what? So if I talk about, let's say, ammonia only NH3, like this, NH3 making NH4 plus, Cl minus. You can see this NH bond is a covalent bond. So this is also a potential question. Ammonium chloride is special because it possesses all three kinds of interaction. If we talk about ammonia as such, it will show hydrogen bonding. But when we are talking about when we are talking about ammonium chloride, it has all three kinds of bonding. तीनों टाइप की बॉन्डिंग है. ठीक है, और क्या है? अमोनियम सल्फेट बन जाएगा NH3. देख लीजिए, इट इज एक्टिंग लाइक अ बेस, रिएक्टिंग विद एन एसिड टू गिव यू सॉल्ट. कौन सी क्लास में पढ़ा था ये? एसिड सॉल्ट, एसिड बेस के साथ रिएक्ट करके सॉल्ट देता है. यही तो हो रहा है. इट्स अ सिंपल एसिड बेस रिएक्शन, गिविंग यू अ सॉल्ट, दैट्स इट, है ना? ठीक है. नेक्स्ट इज ऑफ कोर्स अगर हम मेटल्स के साथ रिएक्ट कराएं. सो लुक एट दिस, जिंक सल्फेट विद अमोनियम हाइड्रोक्साइड. आपको जिंक हाइड्रोक्साइड दे रहा है. ये एक इंपॉर्टेंट रिएक्शन है. और ये भी इंपॉर्टेंट रिएक्शन है कि अमोनियम हाइड्रोक्साइड का FeCl3. सो ये है अमोनियम हाइड्रोक्साइड, अलग से मैंने लिया है यहाँ पे. अमोनिया अगर मैं पानी के अंदर डाल दूं तो मैं लिख सकती हूँ इसको NH4OH. दैट्स व्हाई इट्स रिलेटेड. And this NH4OH can react with zinc sulfate to give you white precipitate of zinc hydroxide and can give you brown precipitate. Basically ammonium hydroxide can react with Fe+3 है यहाँ पे, ferric chloride है. You are getting this kind of a ferric oxide with ammonium chloride. Simple reactions happening. Not my explanation required here. Cool? Now guys, let's see another very important thing which is related with the coordination chemistry. Coordination chem में आपसे इनका पूछा जा सकता है. How can it be made? There is a gas which has a pungent smell which reacts with copper 2+ to give you a particular complex with the coordination number equal to 4. Find the complex ABCD. Or then if we have to talk in terms of coordination chemistry, I can give you huge number of things. Like I can give you things like tell me the hybridization of the complex, tell me the geometry of the complex. So things can be made more complex, I mean to say. ठीक है? Also coordinates with BCl3. Swastika is asking, NH3 is also going to coordinate with BCl3. देखो BCl3 को समझ लीजिए, back bonding दिखाता है. You know that there is a 3p-2p overlap here. So basically this boron is not in the need of a sigma bond with somebody else like ammonia. It is in itself trying to take care of its deficiency. But हाँ, दिखाने को दिखा सकता है. अगर बनाना है तो बना सकते हो because there would be still some kind of deficiency. But understand that BCl3, BF3, only these two have the tendency to form back bonding. Okay, now this tetraamine copper 2 ion complex that you are seeing is deep blue in color. इसका color important है. Similarly cadmium के साथ भी इसी तरीके का आपको complex मिलता है but colorless है. क्यों है ये? आपका homework है. कोऑर्डिनेशन केमिस्ट्री में करा चुकी हूँ ऑलरेडी, रीजंस ऑफ कलर मैं आपको करा चुकी हूँ बहुत अच्छे तरीके से. आई हैव गिवन यू ऑल द पॉसिबल रीजंस ऑफ कलर. Why will there not be any color? Make sure you do it. Okay. Next thing is complex formation with silver. A linear complex is what you get. Okay? A linear complex. Now, when I'm talking about nitric acid, HNO3 Oswald process आपको रटा होना चाहिए step by step. Step number 1 हम ammonia से start करते हैं. We add oxygen to get NO. So the first process is a no. You get a no. From ammonia, using platinum or ruthenium gauge catalyst, 500 Kelvin 9 bar. Critical temperatures, conditions. But okay, इतना नहीं याद करोगे तो चलेगा, but the reaction is important. NO फिर further react कर रहा है oxygen के साथ, right? And then जो NO2 मिल रहा है वो फिर दोबारा react कर रहा है पानी के साथ to give you nitric acid, और जो NO मिल रहा है that can be reused. All these steps should be clear. पहले NO मिला, फिर आपको NO से कैसे NO2 मिला, और फिर NO2 से कैसे HNO3 मिला. देख लीजिए, step number 1 you are getting NO, step number 2 you're getting NO2, and step number 3 you're getting HNO3. Look at the pattern. Guys, best way to master is writing things and finding out patterns in them. If I write all the 3 equations right now, I can observe that here there's just 1 oxygen, here 2, and here 3. So one by one, gradually what's going on is an oxygen is getting added in all 3 processes. We started with ammonia and we are ending up getting HNO3. And that is going to connect dots big time for you guys. Right? Shantanu, my request to you, please make sure, I am not going to give you notes. You have to make your own notes. कभी भी कोई भी notes किसी और के notes नहीं हो सकते. If you have the content in front of you, these are all notes. What I am getting in front of you is not heavy theory. They are the short notes. If you write every slide, you're done for the P block in the major chunk, major aspect. ठीक है? So next is the 4th step where अब क्या करने वाले हैं, हम समझ रहे हैं कि कैसे हम, okay, we got HNO3. But this HNO3, how much can we obtain? We can easily obtain via distillation 68% of nitric acid. क्या 68% of nitric acid को और concentrated किया जा सकता है? Yes, my lord. How can you do that? It can further be concentrated to 98, which is a big number, let me tell you, for the percentage yield, for the percentage of the concentration. Nitric acid 98%. हाथ पे गिर जाए तो जल सकता है हाथ. That is how concentrated it is. Can melt the bones. That's how concentrated it is. Market में it's not sold easily. If you're also using it for a lab, you need proper permissions. That's how concentrated it is. 98%. Light समझा है क्या? Okay, so 98% by mass by dehydration with the concentrated H2SO4. तो जो 4th step है वो ये है कि how can we make it more concentrated. Having said that, let's go on and talk about chemical properties. ठीक है? बहुत रोशन pity. I feel a little pity on me right here. बहुत सारा अभी मेरे को कराना है. So make sure you come back and do it once again. वहीं से click करो और पढ़ो. In fact, revisit the session once again to make good notes. Do not miss anything. Now guys, reactions with metals if I'm talking about. Concentrated nitric acid is a strong oxidizing agent. तो क्या metal को react करेगा? बिल्कुल करेगा. But noble metals को no. They're noble. ठीक है? So अगर मैं example दूँ copper और zinc का, how I have made you remember this so many times is, देखिए कोई difference नहीं है conc nitric acid के साथ. Here also you're getting NO2, here also you're getting NO2. Both places you're getting NO2. So if you're getting NO2 at both the places, what becomes confusing is the reaction with the dilute nitric acid. In fact, conc nitric acid का reaction अगर आप देखेंगे non metals के साथ भी तो भी NO2 ही मिल रहा है. With iodine you're getting iodic acid HiO3 plus NO2. With nitric acid with carbon, you're getting carbon dioxide. You should have got carbonic acid, H2CO3, but it removes water and gives you finally carbon dioxide and water basically. तो यहाँ पे भी NO2 plus CO2. अच्छा, यहाँ पे भी आपको सल्फर से भी एसिड मिल रहा है. बेसिकली नाइट्रिक एसिड के साथ आयोडीन दे रहा है अपना एसिड, आयोडिक एसिड. सल्फर दे रहा है सल्फ्यूरिक एसिड. फॉस्फोरस दे रहा है फॉस्फोरिक एसिड. इजी टू रिमेंबर. और कॉन्क सबके साथ दे रहा है NO2 which is common. But क्या डिफरेंट है डाइल्यूट नाइट्रिक एसिड का रिएक्शन कॉपर और जिंक के साथ. सो रिमेंबर, डाइल्यूट नाइट्रिक एसिड इज वेरी स्मार्ट. डाइल्यूट नाइट्रिक एसिड सेज अ नो टू कॉपर. कॉपर को बोल दिया है नो, और जिंक के साथ शी इज स्माइल्ड. सो विद जिंक she smiled, laughed rather. तो laughing gas प्रोड्यूस होती है जिंक. किसके साथ हंसी? जिंक के साथ. laughing gas N2O in the case of the zinc with dilute nitric acid, but it's a big no to copper, NO. So you know, nitrogen monoxide, NO with the copper. Thumbs up. ठीक है, बिल्कुल सही. स्वास्तिका कह रही है नाइट्रिक एसिड यूज टू मेक एक्वा रीजिया विच डिजोल्व्स नोबल मेटल्स एज वेल. बिल्कुल सही कह रही हो स्वास्तिका. इनफैक्ट अभी वेयर आई एम स्टेइंग जस्ट फ्यू डोर्स अवे देयर इज अ पर्सन हु हैज लॉक्ड हिज डोर. डोर तोड़कर एंट्री हुई है चोर की. चोर पुलिस की कहानी. सो देयर इज अ पर्सन, अ थीफ हु एंटर्ड इनसाइड. And we found out that it was the lock that was like a very good lock, I must say. Very heavy lock, not a sasta wala lock. It was a good one. It was all molten. Pigla hua mila. So yes, that is what probably the thief has procured. This combination, aqua regia, nitric acid with sulfuric acid. है ना? अब हम आगे बढ़ते हैं. लेट्स सी द नेक्स्ट वन. सो हियर ऑल दीज रिएक्शंस आर क्लियर. नाउ लेट्स एंटर इनटू द ऑक्सो एसिड्स. ऑक्सो एसिड्स में भी बच्चा पार्टी याद रख लीजिए वही वाली 3 ट्रिक. कैलकुलेटेड ऑक्सीडेशन स्टेट ग्रेटर है अगर मैक्सिमम से तो परऑक्सी लिंकेज होगा. कैलकुलेटेड इक्वल है मैक्सिमम से तो ऑक्सी, और कैलकुलेटेड लेस देन है मैक्सिमम से तो एलिमेंट एलिमेंट. लेट्स सी हाउ वी आर गोइंग टू यूज इट. चेक इट आउट. ये है आपका एक ट्रिक. कोलैबोरेशन ऑफ what we are trying to make the kind of acid, maybe a peroxy acid, but how do I know the name? So remember it very simply. मैं अगर एक की बात करूं, जैसे अभी हमने फॉस्फोरिक एसिड की बात करी. फॉस्फोरिक एसिड एवरीबडी नोज H3PO4. सिमिलरली अभी हमने आयोडिक एसिड की बात करी HiO3. अगर हम इनमें से फॉस्फोरिक एसिड लेकर चलते हैं, पहले फॉस्फोरिक एसिड से एक ऑक्सीजन हटा दे, we will get phosphorus acid. So H3PO3 guys is a phosphorus acid. एक में से एक ऑक्सीजन हटाया, अस मिला. अस में से if you remove one oxygen from us, from the phosphorus acid, you will get hypophosphorus acid. So H3PO2 is a hypophosphorus acid. अगर मैंने एक एसिड में से which was my H3PO4, I remove water, H2O, I get HPO3. This is my metaphosphoric acid. It can also be written like this, HPO3N. There can be N units of this. अगर मैंने फॉस्फोरिक एसिड H3PO4 को मल्टीप्लाई किया 2 से और फिर पानी निकाला. When I'm talking about multiplying it by 2, I mean H6P2O8 minus water, I get H4P2O7. What is it? Pyrophosphoric acid. When I'm adding one oxygen like H3PO5, this is perphosphoric acid. So ik, remove one oxygen, you get us. Remove another oxygen, you get hypo. Add one oxygen, you get per. In the ik, if you remove directly water, you get meta-ic acid. If you multiply it by 2 and remove water, you get pyroic acid. Got that? Everybody? Hello? Thumbs up? Will you remember it? Hello? Done? If you have noted it down, let's see whether we can use it or not. These are all the different acids that I'm sure now you can figure out. H3PO2 is hypophosphorous acid. Let's check. Wow. H3PO2 indeed we knew was hypophosphorous acid. Right? So do not be now, do not make any mistake in the name, right? Now look at this, ortho is normal. कोई भी आप phosphoric acid बात कर रहे हैं तो you can put in ortho term. Do not get confused. Ortho is normal. जो भी एक acid है, ortho sulfuric acid is nothing but H2SO4. Ortho phosphoric acid is nothing but H3PO4. Why are we writing ortho? ऐसे ही chill है, sophisticated लगता है, sounds very fancy, you know. Rushi is saying, can we apply the same trick to sulfuric acid? Yes. Let's do that in fact, because things are going to be very simple. Let's do it. Let me do it for H2SO4. If you remove one oxygen, you get H2SO3, sulfurous acid. If you remove another oxygen, you get H2SO2, hyposulfurous acid. If you add one oxygen, you get H2SO5, persulfuric acid. Similarly, if you multiply H2SO4 with 2, what do you get? H4S2O8. Remove water, H2S2O7, oleum is pyrosulfuric acid. Aman, clear hai? H2SO4, remove water, you get SO3, metasulfuric acid. Though meta for H2SO4 doesn't exist, it should have at least one hydrogen there. एक hydrogen होना मांगता है. ठीक है? Well, similar thing you can do for iodic acid. If you start with iodic acid, you get per iodic acid. If you add one oxygen, iodous acid. If we are talking about one oxygen less, so H2IO3 के लिए आप start करिए यहाँ से. H2IO2 हो जाएगा iodous acid. HIO और HOI इस तरीके से हम लिखते हैं hypoiodous acid. अब आप देख लीजिए, things will become very simple. Questions होते हैं कितने pi bonds हैं. Both the tricks you have to use simultaneously. Similarly, pyrophosphorous acid. The name was the confusion, no more. Structure was the confusion. Calculated oxidation state for the pyro, H4P2O5. So let's write it like this. Plus 4 plus 2x minus 10 is equal to 0. So guys, 2x comes out to be equal to, can I say 10? Here, ten, 6 plus 3, right? So here I can say I have P and O and a P, right? So यहाँ पे हाँ, this is turning out to be, I think, an exception, right? What is the oxidation state are you getting? And mind you, this is a great opportunity for me to tell you that calculated oxidation state minus maximum, this is not a thumb rule. It has exceptions. That's why I always advise you to write exceptions some elsewhere. जैसे P4O6 is an exception, for example. right? Okay, so here क्या आ रहा है आपका आंसर? Check. हाँ जी, what is the calculated oxidation state that you're getting? Reshmi, if you love chemistry, tell me. Tell me the answer. Calculated oxidation state क्या निकाल रहे हो? जल्दी बताओ यार, be participative here. Right? So do you understand calculated is less than maximum here, but what we are ending up getting is rather a structure where we have oxy bond. So note that. Got that? It will have exceptions. Do not take it as no exceptions will be there. Cool? Okay, now I want you to do it for the hypophosphoric acid also. Can we check here? Plus 4 plus 2x minus 12 is equal to 0. So I get 2x minus 8 is going to be equal to 0, x plus 4. So here at least we have this coming, right? But calculated is less than maximum, chill case. तो जहां पे भी आपको लग रहा है calculated minus maximum वाली जो चीज है, उसमें जो भी exception दिखे, use this video as a tool and tell it to everybody. Make it a forum where you learn. I always keep saying, whatever exceptions they are coming, use them, use the comment section as the platform to help everybody around. And trust me, once it has gone through your typing, right, it will stay in your mind. One exception of the day. Maybe Kumud can help everybody. I want to tell everybody one exception that is important. Similarly, if you just compile everywhere exceptions, imagine how easy it will be, right? Well, similarly, orthophosphoric acid you can of course see, and we have pyro, meta. Now, if we do the same thing for the sulfur, sulfurous, then if we do the same thing for sulfuric, plus 6, the structure everybody knows, pyrosulfuric, apply the trick. Then the peroxydisulfuric acid, H2S2O8, नाम में ही पर है, right? So the same trick you can apply for the chlorine के oxoacids, जैसे कि chlorous acid. Chlorous acid क्या होगा? मैंने बोला HClO3 को याद रख लो, एक एसिड है, उस एक में से एक ऑक्सीजन हटाओ, you get us acid, HClO2. Yeah, as simple as that. अच्छा, माइंड यू, जहां पे भी पर दिखे ना, इसका मतलब पर नहीं लगने चाहिए आपको कि हाँ वहीं पे पर आयो, मतलब पर एसिड है, मतलब कि O और O बॉन्ड है. दो O साथ में है डजंट मीन कि वहां पे परऑक्सी लिंकेज है. ये पर हर जगह परऑक्सी लिंकेज नहीं रिप्रेजेंट कर रहा है. When I'm talking about this per, it can also represent the highest oxidation state, like in the case of the acids of halogen. For example, HClO2, you can see guys, here we have plus 3 oxidation state per acid. When I'm talking about HClO3 plus 5 chloric acid, but per chloric acid, HClO4, there is no peroxy linkage, mind you. Halogens, per acids, does not have peroxy linkage. I hope this thing is hashtag HDCC. ठीक है, डर हटाओ, unknown, known unknown. Let everything be known. Dissipate your fears before you have time. ठीक है, next. The group 18, जहाँ पे fluorides, ये सारे reaction बच्चा बाटी, there's nothing that I can explain here, they're important. ठीक है, highest oxidation state with the highest number of oxygen. Swastika, I can, of course, you're right when I'm talking about ic acid, you're right that it will always have the highest oxidation state. But I'm talking about the calculated oxidation state here. Okay, it will come out to be maximum, the calculated oxidation state for a per acid. Also, the number of oxygens that a particular element can be surrounded with is also where you would see we use a per word. Basically, for per sulfuric acid, we will have a peroxy linkage. For per phosphoric acid, we will have a peroxy linkage. But for per iodic acid, per chloric acid, per fluoric acid, no peroxy linkages. It's just the name per is there because they're surrounded by maximum number of oxygens around. In fact, per fluoric acid doesn't even exist. Right? Well, cool. Xenon की अब बात करते हैं. Xenon forms 3 binary fluorides, namely XCF2, XCF4 and XCF6 by the direct reaction of elements under appropriate experimental conditions. So the product formed depend on क्या ratio ले रहे हो. बहुत simple reaction है. जैसे अगर 1 मोल ले रहे हो या 2 मोल ले रहे हो, 1:5 मोल ले रहे हो, तो क्या होगा? जब हम xenon को excess ले रहे हैं तो बन रहा है XCF2. Otherwise, xenon will have a tendency to form as many bonds as possible. There is crazy a limit if you observe. XCF4, अगर 1:5 का ratio है XCF4 और 1:20 का है, then XCF6. What can also be asked is, using वैसे per, what can be asked is their hybridization. XCF6, XCF2, XCF4 सबका hybridization बच्चा पार्टी क्लियर होना चाहिए. 8 + 2/2, 10/2, 5 will be linear but trigonal bipyramidal. 8 + 4, 8, 9, 10, 11, 12, 12/2, 6. Geometry octahedral but shape square planar. XCF6, 8 + 6/2, 8, 9, 10, 11, 12, 13, 14, 14/2, 7. Shape pentagonal bipyramidal but geometry distorted octahedral. ये याद होना चाहिए, ये आपको 100% याद होना चाहिए. Cool? Okay. So now if I'm talking about the chemical properties, they react with the fluoride ion acceptor to form cationic species. XCF4 का reaction देख लीजिए with SbF5. It is giving you XCF3 plus SbF6 minus. Antimony fluoride is accepting another fluoride. Why will it do so? It has empty orbitals. There is an empty orbital all waiting for the other fluoride to enter. So we get XCF3 plus cationic part बन गया. यहाँ पे देखो anionic भी बन गया. तो क्या ये हमेशा cationic बनाता है part? No, it can make anionic part also. Right? Like in this case, XCF6 plus MF is giving you M plus XCF7 minus. Like this. Okay, now I want you to also note that hydrolysis होता है XCF4 और XCF6 का. क्या बनता है देख लीजिए. आप अगर XCF4 ले रहे हैं, आपको मिल रहा है XC और XCO3. आप XCF6 ले रहे हैं तो सिर्फ XCO3. पार्शियल हाइड्रोलिसिस ले रहे हैं तो XCO4, XCO2, F2, मतलब कि यहां पे आप देख लीजिए XC सिर्फ अलोन एंड XCO3. फ्लोरीन का कोई यहां पे नामो निशान नहीं है प्रोडक्ट में. बट आप यहां देखें तो XCO F4, XCO2, F2, फ्लोरीन का नामो निशान मिटा नहीं है. थोड़ी कहानी अपने आप को बतानी है, थोड़ी कहानी अपने आप से समझनी है, थोड़ी कहानी आपको टीचर बताती है. इनऑर्गेनिक बस यही है. मोर टाइम यू स्पेंड विद इट, बेटर इट बिकम्स, like I said. So with this, we have come to the end of today's session. I have, trust me on this, taken up all the very important reactions. Is this all about P block? No. Is it all about P block? No. How much more? They can be, the sky is the limit. A lot can be more. But I am observing the pattern religiously, taking out all the important stuff there and giving it to you so that you make your short notes right. So I'm sure that you've done that. Let me tell you, the next session is whatever we have done today. See, previous year questions are a way for you to understand the pattern religiously. To understand कब कैसे आया कोई भी question. And चीजें बस थोड़ा सा manipulate होती हैं, रहती similar है. The attire of the question changes but the soul remains the same. ठीक है? So make sure if you find out any exceptions, use this as a platform to enlighten everybody else. Make sure you write everything, whatever we have done. Every slide is important. Hashtag every slide was important. Right? With this is me, Nitika, signing off. See you very soon. Bye-bye.